In this video, we'll be going over how to balance a chemical reaction or chemical equation. So the overall goal, this is based on the law of conservation of matter, is we want to try to get the same number of atoms on both sides of the chemical reaction without changing the molecular formulas. So the only thing you could change are the coefficients or the numbers in front of the substances, of the reactants or the products. Okay, so here's an example. So first we're going to tally the number of atoms on the reactant side and the number of atoms on the product side. So this is a pretty simple. We're going to start off with some simple examples. Okay, so we see that we have one calcium atom over here on the left. Okay, so we have one calcium atom over here. Okay, and then we have two oxygen atoms. So we know there's two right there. Okay, and then over here on the right, so that's why I drew this line right here just to keep it separated here, the reactant side and the product side. So we see that we have one calcium here. So if there's nothing there, that means there's a 1. And then we have one oxygen atom, so which is taken from here, the subscript here. Okay, so we need to do something about this right here. So our one oxygen atom. So this is unbalanced. So we're going to fix that by putting a 2 in front right here. So now that if I put that 2, it means that I have two. So it means I have 2 of these. So I have 1 and 2. So that also means that I'm going to change the calcium also. So we're going to fix that by putting a 2 in front of this calcium here. Okay, and then now it's balanced. It's totally balanced on both sides. So I'm going to do a few example problems or example reactions balancing. For the most part, you'll see that it's like guess and check. But I do have a couple bits of advice for certain types of reactions. All right, so here's this reaction. And we see that we have 3 oxygens here and 2 here. Our K and Cl are actually balanced. So we have 1 on this side and 1 on this side. And then for potassiums on this side, there's 1. Chlorines, there's 1. Oxygen over here, we have 3. And then on this side, we have 2. So you have to kind of go, it's kind of like it's kind of like if you're adding 2 fractions. So if you're adding a third plus a half, you have to make the denominator be the same number. So you'd have to multiply this one. So you have to figure out the lowest number that they have in common. So the lowest number that 3 and 2 have in common is 6. So you'd have to multiply this by 2 and this one by 3. So we're going to put a 3 there and then a 2 there. And if I do that, that'll give me 6 oxygens on this side and then 6 on this side. And you'll see that by putting the 2 there, this is kind of like the issue when you balance, is we just wanted to fix the oxygen, but by doing so, we kind of like inadvertently change the potassium and chlorine. So this is now 2, and this is now 2. And we could easily fix that by now putting a 2 over here on this side. Okay, so now this is going to be 2, and this is going to be 2. Okay, and then it's now balanced. Okay, so let's try a couple more. We have gold. So we have 2 from there being a 2 there. Sulfurs, we have 3. And hydrogen, we have 2 from there being a 2 there. And then on this side, we have only 1 gold. Sulfur, we only have 1. And then hydrogen, we have 2. So here's what I mean by guess and check, is that it doesn't really matter which one we want to balance first. I'm going to go for the sulfur here. So I have 1 here and 3 here. So I'm going to try putting a 3 there. And this will change to 3, and I also changed this to a 6. So I can fix this by putting a 3 there, and this changes to 6. Our sulfurs are balanced, and now I just need to balance the gold, so I'll just put a 2 there. Okay, and then this will become 2. So now it's balanced on both sides. So if there's nothing there, then that means there's a 1 there. Okay, so here's like I was saying, there's a couple pointers that I can tell you about. So look for this to happen on question number 12 on the worksheet that accompanies the video. So refer back to this note or this example when you get to number 12. It's actually a lot harder if you don't do it this way on number 12. So here's an example. It says reaction with PAIs, polyatomic ions. It says balance the polyatomic ion, not the atoms. So try to think of this in terms of hydroxides. So this is hydroxide. This is phosphate. And then this, of course, is another phosphate. So what I want to do is, what this means, what this is saying, is that this right here is, that means I have 2 phosphates on this side. If I look at this side, I only have 1 phosphate, so there's no parentheses here around this phosphate. So what I want to do is, I want to see what happens if I put a 2 here, and that, of course, is going to change the hydrogen and a couple other things here. So I'm going to put a 2 in an attempt to balance the phosphates. Okay, so I'm going to make a line here. So my H's, now I have 6 H's, so 2 times 3 gives me 6. Over here I have 2. Actually, that wasn't all the H's. Okay, I actually didn't count these right here. So I actually have 2 H's from this, as a matter of fact, and I have, since I put a 2 there, now I have 6. So I have a total of, I actually have 8. So I actually have 8 H's. So I'm going to try putting a 4 here, and then now this will be 8. Okay, so my phosphates are balanced. Now my calcium is off. So right here I have 3, and on this side I only have 1. So I'm going to put a 3 there. So this is going to change my calcium. Now I have 3, but it also changed my H's. Okay, I wasn't trying to do that, but that's what ended up happening. So now I have 6 times 2. So I have 6 H's from this. Let me do some side work here. So calcium I have 3. So from this I have 6 H's. And then from this I also have 6 H's. So now I have a grand total of 12 H's on this side. So I'm going to need to change this 4. And I go, what times 2 gives me 12? A 6. So now I fix it to be 12. Okay, and you notice I've ignored the oxygens this whole time. I'm just kind of hoping that they got balanced, and I think they did. So let's check out the let's check the oxygens. So that 3, so the 2 right there means I have 2 oxygens from the 2 being there, and then I have 3 of the molecules total. So it'd be 3 times 2. So I have 6 oxygens from this. So I have 6 oxygens from that. And then the 2 times 4 means I have 8 oxygens from this. So that's a grand total of 14 oxygens. On this side, I have 6 from that, from the water. And then I have 2 times 4 from this. So I have 8 oxygens from this. So 6 and 8 is 14 oxygens. Okay, so the oxygens check out. The calciums, I have 3 from that, and then that 3 there means I have 3 calciums, so the calciums check. So I have 3 calciums, and then I have 3 calciums. And then hydrogens are already checked. Phosphorus, you'll see that I have, so for phosphorus I have 2 from that, and then that 2 means I have 2 phosphoruses from that. So this whole thing is actually balanced now. This would actually be a lot harder if I didn't balance it in terms of polyatomic ions at the beginning from that 2 being there. Okay, so let's try one more, a combustion reaction. So for this, take a look at 4, 7, and 9. These all are combustion reactions on the worksheet that goes with this. So here's the reaction. Use for combustion reactions, balance all combustion reactions, balance the carbon first, this carbon. Next is to balance, if you do it in these steps, they're a lot easier than guessing and checking just randomly. So then balance the H's next, and then save this for last. Save this, the reacting oxygen for last. Okay, so if I go in that order, I see that I have 6 here, so I'm going to put a 6 there, and carbon is balanced. Okay, and now I have 12 H's, so I'm going to put a 6 there as well. That gives me 12. Now for oxygens, I have 6 times 2, so I'll use a different colored pen so we could keep track. Okay, so 6 times 2 gives me 12 oxygens from the CO2, and then 6 from the water, so that's a total of 18 oxygens. Okay, so what times 2 gives you 18 is 9. Okay, and then this will be a 1 right there. Okay, and it should be balanced. If you happen to have, on this step, if you have an odd number of oxygens here, then use a fraction on the O2 on the reactant side. So what I mean is, let's say this was like 19 instead of 18, then you'll see that it won't be a whole number if you so you'd have to go like what you'd have to, in that case, if this were 19, you'd have to go like what times 19, what times 2 gives me 19. So you'll end up with actually 19 over 2 in that case. Okay, so you would go ahead and put a 19 over 2 here, and then you would actually multiply the whole entire reaction by 2 to get rid of that fraction. Okay, and then that would become 19. So we'll look at, I think one of these or 2 of these may be an example of that. So use a fraction if you end up with an odd number of oxygens there. Okay, so that concludes the video, and go ahead and try the worksheet that goes with this. Oops.